All right, this is the last section of Unit 2. 2.5 is on linear inequalities and absolute value inequalities. Up until now, we've been working with equations. And in math, an equation is called an equation because it has an equal sign in it. An inequality is called an inequality because they are not equal to each other. So you might see the greater than symbol, the less than symbol, greater than or equal to, or less than or equal to. You can think of the word unequal is in the name. So today's objectives are all going to deal with inequalities, whether we're solving them or just getting used to the notation. One thing to keep in mind, if I said, let's say we solved something and I got the answer x equals 5. Well, I think we can agree that is one answer. That is one solution. But what if I solved an inequality and I got this at the end? X is greater than 5. If I said, okay, how many answers are there? Well, hopefully you tell me there's an infinite number of answers because 6 would be an answer. 6 is greater than 5. 10 would be an answer. 11.18 would be an answer. 35 and 1/4 would be an answer. And I could keep going. Any answer bigger than 5 would be an answer. So when we deal with inequality answers, we're going to write our answers using something called interval notation because there's more than just one answer. So what I want to do first is to explain what interval notation it is. This is something we're going to see down the road as we get further into this class. It can look intimidating at first, but once you understand the basics of it, it's really pretty doable. So with interval notation, if you see parentheses, around the numbers, that means the endpoints are not included in the interval. So for example, if I saw this, that would mean I want any number between 5 and 7 would be an answer, but not 5 and 7. Not the endpoints themselves, but 5.1 would be an answer, or 6.82 would be an answer, but not 5 and 7. Now, on the flip side, if we have brackets around our interval, that means the endpoints are included. So if I saw this, that would mean anything between 5 and 7 is an answer, and 5 and 7 are answers themselves. The endpoints are included. So it's a subtle difference, but it does change your answers. So I just want to go over different ways and meanings that this notation can be seen. So if I gave you the interval a to b, notice parentheses, so a and b are not included. Another way it can be written is called set builder notation. And I'm going to write it up here and then we'll talk about what it means. A lot of the times this notation will freak people out. But all it means, it's read as, okay, it's the set of all x's, all numbers, and then this vertical bar is such that, and then this back part just says, hey, these numbers have to be in between a and b, but notice when I drew the inequality symbols, they do not have the equal to bar under them, meaning I don't want to include a and b. So this and this are saying the exact same thing. It's just two different ways of writing it. If I wanted to visually look at this on a number line, what I would see, if I drew a number line, I would plot my two values. A and B. And then to indicate the answers, we would do a parenthesis on A, a parenthesis on B, and we would shade everything in between, meaning everything in between is an answer, but not A and B. All right, next one. Still between A and B, but this time brackets on both. So what we would see for the set builder notation, it'd be all the x's such that I would have to stay between A and B, except I can be equal to them as well. A and B are also answers. So on a number line, it would look almost darn near identical, except I would see bracket, bracket, and everything in between is an answer. Okay, next one. See if you can visualize what this would look like in words. So I want to stay between A and B. A could be an answer, but not B. So if we think about what this would look like in set builder notation, it's all the x's such that, I'm going to set it up here. Do I need equal to bars on anything? And you should say yes, just on the A. I can be equal to A, but not B. So if I graphed this, what I would see, same exact setup, I would include A, but a parenthesis on B, and then shade in between. Okay, next one's just flip-flopped. Jeez, that's a mess. This time I want the equal to bar on the B. So when I graph, I want a parenthesis on A, bracket on B. Everything in between is an answer. Okay, now look at the next one. The next one is different. This is saying, hey, anything after A is an answer. I don't care how high you go. In math, this is the infinity symbol. For those of you that don't know, that just means A onwards. I don't care how high. So in set builder notation, here's how we would have to say this. All the x's such that, I'm just going to say, x is greater than A. I just got to be bigger than A. I would not want the equal to bar because the A does not have a bracket. So if I were to graph this on my number line, I just have A because B is not mentioned. I'd want a parenthesis on A, and then everything after is an answer. A lot of the times they'll bold the arrow, meaning I just keep going. Fun fact, infinity, if it's mentioned in the notation, it will always have a parenthesis. There will never be a bracket with infinity because I can't reach it. It's not a number. So a bracket should never, ever, ever be with the infinity symbol. Next one is just the opposite. Well, not quite the opposite, I guess. We still want to be greater than A, except I can also be equal to A. So bracket and then everything onwards would be an answer. Now the next one, negative infinity works the same way. We're just going the other direction. So this means B is the highest I could go up to, or everything below would be an answer. So all the x's such that we would want to say x is less than B. And I don't want the equal to bar because I don't have a bracket. So if I was graphing this, I'd place B on the number line. I would do a parenthesis, and I'd want everything under B. Next one, same thing, except because B has a bracket, I can be equal. And then I want everything less. And now the last one, let's see if we understand what the last one represents. Because if you get this interval notation idea, the rest of this lesson will kind of fall into place. Negative infinity to infinity, what would that mean about my answers? Everything is an answer. All numbers are answers. This is all real numbers. So in interval notation, really they would just do this. If you see this, it kind of looks like a fancy R. That means all real numbers. The entire real number system is an answer. It's the whole thing. It would be hard to sketch this, but I guess if we wanted to sketch it, it would literally be the entire number line would be shaded. Everything is an answer. All right, so let's throw some numbers in. And if you can do what I was just doing with letters, with numbers, it's even easier. Express it in set builder notation and also graph it. So in set builder notation, it's all x's such that I want to be between -1 and 4. And then I have to decide, do I want an equal to bar on anything? Well, since the 4 has a bracket, I can also be equal to 4. On my number line, you don't have to fill in every single number. I'm okay if you do -1 and 4. We'll get the point across. I would want a parenthesis. I would want a bracket. And everything in between is an answer. So if I asked you, and I've been known to ask this, if I said, hey, is 3 an answer? You would say yes, because it's in my shaded region. If I said, hey, is -2 an answer? You would say no, it's not in my region. If I said, hey, is 4 an answer? You would say yes, because we can be equal to 4. If I said, is -1 an answer? You would say no, because we can't include -1. We can go right up to it, but we can't include it. Okay, next one. Set builder notation, all x's such that I want to be between 2.5 and 4. Do I want equal to bars on anything? You should say both. I can include both this time. So my graph, 2.5 and 4. I'd want a bracket, bracket. Everything in between is an answer. Next one. So think about what this means. -4 and everything bigger. Everything bigger than -4 is an answer. So in set builder notation, I cannot draw these to save my life. It's all x's such that if x can be everything bigger than -4, x is greater than -4. Do I want the equal to bar? You should say no, because we have a parenthesis. So we'll have our -4. I want everything greater, so I'm going to shade to the right with the parenthesis. Okay, now we're bringing back something we saw in the first unit, the intersection and the union symbols. So if you see it looks like an N, I want you to think what they have in common. That was a trick one of my students thought of. So it's the overlap. What do they have in common? What do they share? I think the easiest way to visualize what these two intervals would have in common is to make a number line. So I would have, let's do my 1 and my 4. And here's what this guy would look like. So 1 to 4. And now I'm going to do, here's 2 and 8. This is not drawn to scale, but it will get the point across. 2 and 8. And I would have a bracket, bracket, and shaded. So now your answer, what they have in common, the intersection, where is the overlap? Where they're both in the same spot at the same time. You should say it's from 2 to 4. Right? They're in the same spot at the same time from 2 to 4. That's where the overlap is. So I would say bracket, parenthesis, because the first one did not include 4 and the other one included 2. Okay, let's try the next one. This one wants the union. So if I graph them again on a number line, just to show you what would happen. Now remember, the union symbol is like or in math. This or that. So think of a marriage, a union. You brought this to the marriage, you brought this to the marriage, now it's all of ours. So it's everything. So this entire thing would span from 1 all the way to 8, a parenthesis on 1 and a bracket on 8. That would be the union of those two. Okay, one more here. So this one, I'm going to put my 6 here. It would be everything under 6, because it's going to negative infinity. And the other one would go from 2 to 9, bracket, parenthesis. So now this one wants the intersection, what they have in common, the overlap. So you should say, if you look at where the overlap is, the shared region would be bracket 2, parenthesis 6. All right, now we'll kind of speed some things up here. If we're solving inequalities, we solve them the same way we would an equation. There's one catch. If you multiply or divide both sides of an inequality by a negative value, you need to flip the inequality symbol. We'll talk about that when we come across it in an example. So solve and graph on a number line. So I want to get x alone. We're going to do it the same way we would an equation. So the first thing I want to do is subtract 3. And the last step to get x alone is to get rid of the negative 2. Since it's multiplication, I'm going to divide it. Now, because I'm dividing both sides by a negative number, hopefully you agree, our numbers turn opposite. Well, everything turns opposite, including the symbol. So if you multiply or divide by a negative, the symbol flips as well. We didn't have to worry about that with equations because equals was equals. So this is my answer. Everything greater than or equal to negative 4 would be an answer. If we wrote that in interval notation with parentheses and brackets, it would look like this, right? Everything greater than negative 4. So negative 4 onwards, and I'd want the bracket with negative 4 because I have the equal to bar. If I graphed it on a number line, I'd have my negative 4, bracket, everything shaded to the right is an answer. Okay, let's try the next one. I need to get my x's together, so I think I'm going to subtract x. The symbol does not flip with adding and subtracting. It is just the multiplying and dividing by a negative. Add 4. Divide by negative 3. Since I'm dividing by a negative, the symbol is going to flip-flop. So I get x is less than negative 3. If I wrote that in interval notation, this means negative 3 is the highest I can go. And I'd want a parenthesis because I don't have the equal to bar. My graph. Everything under negative 3. Okay, now this next one, we have the dreaded fractions. We're going to do exactly like what we did when we solved these as equations. Remember, this is where we thought of the whole thing in parentheses, and we multiplied by something to get rid of the fractions. The least common denominator. So if I look at the things in the denominator, what is the smallest number that 4 and 3 will go into? It's a 12. So 12 divided by 4 for the first guy would be a 3. But there's still the x plus 3. When I give 12 to the next one, 12 divided by 3 is 4, but there's still the x minus 2. And 12 divided by 4 for the last one is 3, but there's still the 1. Great, now the fractions are gone. So I get 3x plus 9, 4x minus 8, I'm distributing, plus 3. Combine like terms. And now I'm going to get my x's together. So I'm going to subtract 4x. And I'm going to subtract 9. And then I have to divide by the negative 1. The symbol is going to flip because I divided by a negative. So x is less than or equal to 14. In interval notation, that means I have to stay under 14. 14 is the highest I can go. And I should have a bracket because I have the equal to bar. If I graphed it, everything under 14 and 14 would be an answer. Okay, these last two are kind of the oddball ones here. I would distribute. And if I subtract 2x over to get my x's together, look what happens. My x's are gone. There's no variable. If I look at what's left, 8 is greater than 3. Does that make sense? Yes, well, yeah, 8 is greater than 3. So because my variables disappeared completely and what's left makes sense, this answer is all real numbers. Everything is an answer. So you might just see this symbol as well. Everything works. So I'm not going to make the graph because it would just be the entire number line. If we wrote this in interval notation, we would say negative infinity to infinity. Everything works. Okay, and let's do the last one here. If I get my x's together, so I'll subtract x. And look at this, the variables disappeared again. And if I look at what's left, 7 is less than or equal to negative 2. Well, that doesn't make sense. 7 is not less than or equal to negative 2. Since the variables canceled and what's left doesn't make sense, this is no solution. Or the symbol they might use for no solution is that. You cannot make a graph of something that's no solution. Nothing would be shaded. All right, the last thing that I want to do with inequalities is kind of look at some of the goofier inequalities that will appear. So we have something called compound inequalities. This is just an inequality made up of multiple inequalities. Kind of like in English, a compound sentence is 2 or more sentences. Well, this is 2 or more inequalities. So solve and graph the solution on a number line. So notice I have 2 inequality symbols. Don't let that scare you. We're going to solve it the same way. So if I look at where the x is, to get x alone, I'd want to get rid of the 1 first. So we would subtract 1. But this time you have to do it 3 times. You have to do it to every single side. So then I'd have negative 4 is less than 2x is less than or equal to 2. And then the last step to get x alone would be to undo this multiplication. So I'm going to divide. So I get negative 2 is less than x is less than or equal to 1. There is the answer. So this means x has to stay in between negative 2 and 1. If I wrote this in interval notation, I'm going to stay in between negative 2 and 1. Negative 2 would have a parenthesis, and 1 would have a bracket, meaning 1 is included, negative 2 is not. If I made my number line, I'd want a parenthesis, bracket. Everything in between is an answer. Everything outside of that is not an answer. And finally, we have the absolute value inequalities. Remember, in the last section, I said if you were solving an absolute value equation, you would get two answers out. Because technically, like on this one, two numbers would make that work. The absolute value of 2 is 2, and the absolute value of negative 2 is also 2. It's going to be the same concept for inequalities. So let's solve and graph the solution on a number line. Remember when we did the equations, I said you need to get the absolute value bars alone. Well, if I look at this first inequality, they are alone. So I'm ready to get rid of the absolute value bars. So we're going to make just like what we did with the equations. We're going to make two of them. So one of them will be the x minus 4 is less than 3. Exactly what I have without the absolute value bars. The other one will be x minus 4, and we're going to have a negative 3, and the symbol flips. I didn't have to worry about that with equations because the equal sign was the equal sign. That's the only catch. Now we're going to solve. So plus 4. So I get x is less than 7. X is greater than 1. So now I'd like you to write this answer in interval notation. Think about it. X is less than 7, but greater than 1. What would that look like? I have to stay less than 7, but be bigger than 1. Hopefully you're thinking that, right? I have to stay between 1 and 7. If I graphed it on a number line, everything in between would be an answer to that inequality, but we don't include 1 and 7. Okay, the next one, we have a little bit more work to do because notice the absolute value bars are not by themselves. This negative 2 and 7, we got to get rid of them. So I'm going to subtract 7. Now I have to get rid of the negative 2 since there's multiplication. I'm going to divide. The symbol flips because I'm dividing by a negative. And now that the absolute value bars are alone, I'm going to set up my two inequalities. So the other one's going to be greater than or equal to negative 10. And now let's solve. So subtract. Divide. So I get a fraction, 5/3. And the other one, negative 5. So let's think about this one. What is this saying? I have to be less than 5/3, which is like 1 point something, and I have to be greater then negative 5. So think about what that would look like as an interval. So it's going to be negative 5 to 5/3. And now we have to decide parentheses, brackets, or some mixture. Well, since I have the equal to bars, I do want to include them. So I would be between negative 5 and 5/3. On my number line, again, not drawn to scale, but we'll get the idea across. I'd want bracket, bracket, everything in between is an answer. Make sure to take good notes on this one. This one, people have a hard time with this type. It's small but deadly. So notice, good news, the absolute value bars are alone. So what I'm going to do first is write my two equations. So I'm going to have 7 is less than 5 minus 2x. And I'm going to have a negative 7 is greater than 5 minus 2x. And now let's solve each. So notice I'm dividing by a negative 2, so the symbol flips. And the other one, I'm dividing by a negative 2, so the symbol flips. Now, my students sometimes have a hard time with interpreting these if the x is on the right side. So what you can do to make this a little user-friendly, we can rotate the whole thing around. So this means the exact same thing as the piece in right above it. I just turned the entire thing around. I didn't flip anything. I just turned it around. Think of like a revolving door. I'm going to do the same thing for the other one, just because I think it's easier to read that way. So this means I need to stay less than negative 1, but I need to be greater than 6. Less than negative 1 or greater than 6. If you say this, you're going to be wrong because it's not actually between them. I either want to stay less than negative 1 or greater than 6. So it's everything is an answer except the stuff between. So when I write this in interval notation, that interval is less than negative 1. This interval is greater than 6, and in between them, I'm just going to put the union symbol, which again means or. So it's saying like, hey, this or this, but not in between negative 1 and 6. So if I was graphing this on a number line, I'd have my negative 1, and I'd have my 6. I'd have a parenthesis, everything left, or I'd have a parenthesis on 6 and everything right. We do not want the stuff in between. So that one's kind of a little bit trickier. All right, I'd like to end with the story problem. Acme Car Rental Agency charges $4 a day plus 15 cents per mile, where Interstate Rental Agency charges $20 a day and 5 cents per mile. How many miles must be driven to make the daily cost of Acme Rental a better deal than Interstate Rental? All right, well, we're going to have a variable. What will my variable represent? Look at the question. How many miles? So my variable is going to represent the number of miles. That's what I'm looking for. That's my unknown. So let's do Acme first. What do they pay for? $4 a day plus 15 cents for every mile. So I'm going to be paying $4 plus. Now if it's 15 cents per mile and I don't know how many miles I'm going to drive, I'm going to have to write that as 0.15x, because I don't know how many I'm going to do. The 4 should not have an x because I'm not paying the $4 per mile. It's just $4 a day. Now let's do interstate. They charge $20 a day and 5 cents each mile. So 20 plus the 5 cents times x, because I don't know how many. Now, people are often tempted to do this. We do not want an equal sign between them. I don't want to know how many miles will they be the same price. If you look at what I drew a rectangle around, how many miles must be driven for Acme to be a better deal? So if you think in terms of money, if you're looking for the better deal, you would want it to be cheaper. So if I want the red side to be cheaper than the blue side, we'd want it to be less than. Now you don't want the equal to bar because I don't want them to be equal. I want the red side to be better, cheaper. So that's what we're going to solve. So if I was to solve this, I would get my x's together. So I'm going to subtract. So 4 plus 0.10 is less than 20. Subtract 4. And then the last step would be to divide because I have multiplication. So if we divide, we get x is less than 160. So again, I'd want you to tell me, what does this mean? Well, they were asking how many miles for the better deal. This would represent driving fewer than 160 miles would make Acme a better deal. As soon as I drive over 160, then it's no longer a better deal. But anything under 160, I would want to go with that.